Good afternoon, everyone, and welcome to this afternoon's webinar on the commonly used statistical treatment and analysis in nursing research, hosted by the University of St. Salle College of Nursing and Center for Research and Engagement. One of the major challenges any researchers faces in reducing complex data is a manageable one in order to describe, explain, and model them. This is where statistics comes in. Using appropriate statistics, you will be able to make sense of the large amount of data you have collected so that you can present the research study coherently and with justification. However, it is an area that is often approached with discomfort and anxiety, if not actual fear. That is why it is a privilege for all of us this afternoon to listen into this topic. To start with, may I invite everyone to pause for a while and feel the presence of the God Almighty as our opening prayer.
Let me be the change I want to see, to do with strength and wisdom all that needs to be done, and become the hope that I can be. Set me free from my fears and hesitation. Let the courage and fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark in faith, service, and communion. Let us start the change we want to see, the change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
Not the light, I can be the spark. Faith, service, and communion. Let us start the change we want to see, the change that begins in me.
Jesus in us.
Jesus in us.
Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. To officially welcome us all, we are pleased to have with us our Level 3 chairperson in the college, Dr. Tony Ann Lachica.
Thank you so much, Ms. Teen. Good afternoon, Dr. Shaila. Good afternoon to our invited resource speaker, to the nursing research facilitators. Good afternoon. Also to my colleagues in the College of Nursing, and also our Level 3 students and other students from the College of Nursing. Welcome to our webinar this afternoon. Let's learn the way to torture, or for nurses, dissect and study the data you will be gathering, or we have gathered for some, so we can be able to let them speak and express, for us to draw out our findings and conclusions purposefully. As we have invited one of the most keen and trusted statistician in the university, May her talk today will build up your foundations on the common stat tools used to treat research data. To the participants, thank you for taking time out from your work, and for the students from your classes, your joining here shows your interest and passion to learn more research. So on behalf of our college dean, Dr. Jocelyn Flor Cadena, and also my fellow officers, I welcome you all in this webinar. Good afternoon.
Thank you so much, Dr. Lachika. And now to present to us the objective of this webinar, as well as the introduction of our resource person, may I give the virtual floor now to Mr. OJ Jimenez.
Thank you, Miss. Sorry for the. Thank you, Miss Christine Condes, for that. It is my privilege to actually present to you the webinar's objective for this afternoon. At the end of this webinar, the learners are expected to recognize common statistical treatment used in nursing research analysis, distinguish relevant tools in processing quantitative data findings, and appraise ways in elevating the standard of employing accurate statistical treatment through the use of technology. And also, it is equally an honor to present to you and to introduce you this afternoon's expert and highly acclaimed statistician, as mentioned earlier. It is with a great honor and pride to be tasked to you a person who has achieved a lot, a chemical engineer and a teacher. She has a license for both professions, a graduate of BS in chemical engineering with a double master's in technology from Technological University of the Philippines in Manila, and a master's in education major in math from University of St. LaSalle. A doctoral degree of Doctor of Philosophy major in Technology Management from Carlos Hilado Memorial State College. She also has an online certificate in Inferential Statistics from University of Amsterdam through Coursera as a DOST grant. Currently, she is the chairperson of Mathematics Department from College of Arts and Science here in our university. She also teaches statistics, trigonometry, math in the world for the undergrad, and educational statistics and statistical methods for the graduate school. Ladies and gentlemen, let us all welcome our very own Dr. Geraldine Abella. A round of virtual applause, please.
Good afternoon. Mayong hapon sa tanan. No? Good afternoon, Doc Tony. Good afternoon, Doc Shaila. Good afternoon to the faculty of the College of Nursing and to all the participants in this webinar entitled Common Statistical Treatments and Analysis in Research or Nursing Research. I am very honored to be invited by personally by Doc Shaila and Doc Tony to be the resource speaker of this webinar. I prepared a very simplified approach and straight to the point presentation so that every one of you, because I know your background in statistics some of you find it difficult to comprehend some of the tests that you will be using in your research, which you will be conducting, or some of you maybe are already starting on their research. So I made it that the presentation would be easily, you can easily comprehend it, it's straight to the point, and identified only the statistical treatments that are commonly used in nursing researches. I would also like to take this opportunity to the beloved dean of the College of Nursing, who is maybe is also here, who also part of the who invited me to be the resource speaker of this webinar. Can I now share my slide?
Yes, doctor.
I would also like to thank the Center of Research and Engagement and the College of Arts and Sciences for allowing me to do this webinar. I divided the presentation into 3 sections or 3 parts. So the first part, I'm going to have a quick review on basic statistical concepts. The second part would be about descriptive statistics, which I'm going to present the common statistical tests that are used in descriptive analysis. And the third part would be about inferential statistics, okay, which I would discuss the process involved in hypothesis testing, which is used in inferential analysis. I'm going to show you the different types of parametric tests and non-parametric tests, which include test of difference and test of relationship. By the way, as I continue with my presentation, you can raise your hand anytime so that you will be acknowledged. You can ask me questions, or you can even, because I made this presentation interactive also. So later, I'm going to ask you questions. Write your answers in the chat box, and those who have many correct answers will, of course, be given a reward. So prepare your GCash. May budget. But anyway, so now please participate in the questions that I'll be giving. So it's just a quick review of the basic statistical facts that I'll be presenting. So these basic statistical concepts, okay, I have to present this so that, as what I've said, it would be easy for you to comprehend the different statistical analysis, descriptive and statistic analysis that I'm going to discuss in the second part and on the third part of the presentation. So let's start with the first part, wherein I'm going to discuss some basic statistical concepts. Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusion from data taken from Elementary Statistics by Bluman, 7th edition. And statistics is the backbone of research. That's why this seminar, okay, was organized to help you in your research. Your understanding in statistics is very essential in your research journey. So to name a few sections in making your research, you need to work with the statistician. So you find a friend, okay, you find a statistician who will help you from the research title from the research title to the variables, population and samples, specific objectives, sampling techniques, statistical treatments, and for the results and discussions. There are 2 main areas in statistics: descriptive statistics and inferential statistics. In descriptive statistics, it consists of the collection, organization, and the presentation of data and performing descriptive analysis to describe the basic features of a certain group, in which these features could not be used outside of the group. These are 3 cases which falls under descriptive statistics. First case is
Doc G,
Yes,
sorry,
yes.
sorry to cut you, but I think we need to adjust your screen because it's actually one half only of the screen that we can see from our end. I
Okay.
think, thank you.
I don't know what happened, but what I see here on my screen, it's also, I'm going to stop sharing again and repeat, no? So since ang nakita ko is a whole page man, let me check. Is it okay now, Doc Tony?
I don't know from Doc Shi, maybe.
Doc Shai, is it already okay?
Yes, Doc.
Thank you, Doc Shi. Thank you, sir.
So going back, I have already defined statistics. Now, statistics is very important because it is the backbone of research, and in your research journey, you need your knowledge in statistics is very essential from the start, from the formulation of your research title up to the results and discussions. There are two main areas of statistics: descriptive and inferential statistics. So when you say descriptive statistics, it involves the collection, the summarizing the data and presentation of the data. It describes the basic features of a certain group. However, these features could not be used to describe the other features of another group. So these are three examples of descriptive statistics. As of April 2020, there were 6.8 nurses per 10,000 population in Region 6. So this is an example of descriptive statistics because this fact is only true in Region 6. You could not use this data in Region 7 or other regions in the Philippines. Another example of descriptive statistics is this. 50% of the respondents voted for the return of face-to-face classes. Now, this result is only true for a group of participants or respondents who participated in the survey. Then we have the third. Doc Shai and Doc Tony, is it now okay? Do we have a problem in my slide?
It's okay now,
No?
Doc.
Okay. Okay. Then another scenario which falls under descriptive statistics is this. An average Filipino is 156.41 centimeters tall. So this data is only true for all Filipinos, but not true, of course, no, for Americans, for Europeans, because this data is only for the Filipino, the average height of the Filipino, which is 156.41 centimeters. Now, in the second area of statistics is inferential statistics. So this involves hypothesis testing, regression analysis, and predictive analysis. This is in this area where you take the data from the sample and draw conclusion, which is not only true from the sample, but it is also true for the population. So I picked three scenarios, which are examples of inferential statistics. One is, there is a significant difference in the level of nursing competency between male and female nurses. So a statistical test was applied here to draw a conclusion that the nursing competency level of the nurses when they are grouped according to sex are significantly different. Another scenario which falls under inferential statistics is this. According to Okta research, the number of COVID cases will continue to decrease by next month. This is an example of predictive analysis. And then we have the third. A recent study shows that exercise is related to a decrease of serum cholesterol. This is a relationship study between the two variables, okay, exercise and decrease, or rather amount of serum cholesterol, where a test of relationship was applied to draw this conclusion. And that falls under inferential statistics. The process of hypothesis testing was conducted in order to draw a conclusion that there is a relationship between the variables, type of exercise, and amount of serum cholesterol. Now, after formulating a research title, you have to know the variables that you are going to measure in your research. But what are these variables? A variable is a characteristic or attribute that can assume different values associated with the population being studied. For those who have already taken up units and statistics, may I ask you, what are the two categories or what are the two types of variables in research? Anybody? You may raise your hand and unmute your microphone, or you may send your answer in the chat box. Okay, so there's one who sent her answer, independent and dependent. Then that's from Miss John Ray. Then Miss Justin Hope sent the same answer. So the variables that you have sent are actually categories of variable if the research is experimental. Are there other answers? Because there are two main types of variables. Okay, another, I received one, nominal. Nominal is a level of measurement in statistics. Sige pa, before I give you the answers. Dependent and independent lang ilangan na dumduman. So there are two types of variables. These are qualitative or categorical variable, and the other is quantitative variable. When you say qualitative or categorical, as the name implies, these are variables that can only assume qualitative values, such as sex. Sex, okay, there are two possible values. What are the two possible values? Sex is a qualitative, which is different from the number of sex, right? So can you please give me the possible values for sex as a qualitative variable? Yes, correct. Thank you. So that is male and female. Marital status is a qualitative variable. So because there are about 3 or 4 qualitative values that it can assume. Married, widow, single. So these are qualitative variables. Religious affiliation, department in the hospital, like emergency care unit, what else? Delivery unit. I do not know the correct term. So these are qualitative or categorical variables. Then if the variable can assume numbers or quantitative values, then we call it quantitative variable, which is categorized into two: discrete and continuous variable. When you say discrete, its values are counted, and it can only assume whole numbers, such as, for example, the number of participants in this webinar today, or the number of teachers in the College of Nursing. So we could not say, or the number of patients admitted in a hospital. We count the number of patients, we count the number of participants attending in this webinar. So it could not assume decimal values. When you say that there are 110.5 patients admitted in a hospital because miss 0.5 kumpo lang isa. No. So 0.5 is not a counting number. 0.5 is not a whole number. 0.3 or other decimal values. So when we collect the values for a discrete variable, we count it. For continuous variable, this is a quantitative variable in which its values are measured. So you use a research instrument, such as the body temperature of a person. So it's a continuous variable because it can assume not only whole numbers, but decimal values also, like the weights of the students, like the height of the students. So these are continuous variable. You use an instrument. You use a weighing scale to measure the weight of newborn babies. You use a thermometer to measure the temperature, the body temperature. And other variables, again, continuous quantitative variables. So the difference is discrete, you count the values; continuous, you measure the values. Let's have a quick review on this. So you give me the answer in the chat box. Determine whether the variables is qualitative or quantitative. If it is quantitative, tell me if it's discrete or continuous. So on quantitative, your answer must be discrete continuous or continuous quantitative. Number 1. Number of active cases or COVID cases in Bacolod City. What type of variable is this? Okay, so we have already a correct answer. Okay, number 1, who sent me the correct answer? So it's Miss Salve. Am I right? Dr. am I right? No? So Miss Salve, because the correct answer is quantitative discrete. Second, how about weights in kilograms of newborn babies? What is this? Yes, you are correct. Sean, the answer is quantitative continuous. Next, clinical departments in a hospital. What type of variable is this? Yes, your answer, Christine. So it's John Rev Salvio. Your answer is correct. It's qualitative. What are the different clinical departments in a hospital? If you may unmute your microphone, can you give me one clinical department? So yes, so radiologic, pediatrics, OR, surgery. So thank you very much. So these are qualitative data. That's why this clinical departments in a hospital is a qualitative variable. How about types of patient care? Qualitative or quantitative? Yes, correct, qualitative. How about glucose concentration measured in grams per deciliter? Yes, you are correct, Ashel. It's quantitative continuous. Now, you mentioned a while ago, independent and dependent variables. Dependent and independent variables are variables used in experimental research. And when you say independent variable, this is the variable that is being controlled in the study, and dependent variable, this is the output variable or the result variable. Now, that is if the design of the study is experimental. Now we go to population and sample. So why is there a need to get a sample from the population? When we say population, it is the entire group that you want to draw conclusions about. So if you want to describe the average or the academic performance of your student in your class, then your conclusion is for the entire class of section A. But since the class is very large, you will only take a sample. A sample is a subset of the population that you will collect the data from. So if the sample is or the population is very large, there are two reasons why a sample is used. Okay. It is very expensive to collect the data from every member of the population and the time as well. Remember, when you conduct a research, it must be time-bounded. So basi maabtan ka isa ka tuig or dua ka tuig when you are going to collect the data from every member of the population. That's why you can collect a sample, process the data, and then apply statistical tests, draw the conclusion from the sample, but that conclusion from the sample is also applicable for the population. So, population or sample. For number 1, all private medical doctors participated in the survey on the advantages and disadvantages of practicing telemedicine. What is this? Population or sample? Correct. It's population. Number 2, a number of selected students joined the 2020 National Nursing Convention. Population or sample? So in the second statement, is this a sample or a population? Yes, so correct. So this is a sample. Next. Now we go to, so one of you answered, no? So when I asked you the types of variables, one of you answered nominal. So ari na ang sabat, no? So you answered nominal. There are 4 levels of measurements, and this is one of the important statistical concepts. Why? Because after identifying the variables in your research, you also have to identify the measurement level of each variable, because the measurement level will tell you the appropriate statistical test to be used in order to answer every objective in your, or specific objective in your research. There are 4 levels of measurements: nominal, which is the lowest level, ordinal, interval, and ratio. In the nominal level, the variables that are measured here are qualitative variables. Okay, wherein the qualitative values can be put into different categories, mutually exclusive categories, such as the different year levels: first year, second year, third year, and fourth year, such as different private schools, such as the different types of patient care. So these are measured in the nominal level. So most of the qualitative values are measured in the nominal level. However, there are also a few quantitative variables that are measured in the nominal levels, like these numbers in the jersey. So ang numbers sa jersey is classified as nominal, are measured in the nominal level. Number 1 does not indicate that if the jersey number of a player is number 1, does not mean that that player is the top player of the team. So it's a number that makes him unique. Amo na iyang ginpili iyang number. Your ID number, the license number are measured in the nominal level. Now, let's go to the next level, which is the ordinal level. In the ordinal level, okay, the difference between ordinal and the nominal level is that, okay, we also measure qualitative values in the ordinal level. However, its difference is the data can be ranked from lowest to highest. Qualitative values, but the data can be ranked like small, medium, large, or like the rank in the military, from the lowest rank to the highest rank. However, we could not give the exact difference. Likert data like strongly agree, agree, disagree, strongly disagree are measured in the ordinal level. We know that there is a difference, but we could not give the exact difference between small and medium, medium and large. Okay, so ordinal level. In the third level, we call it interval. In the interval and ratio, the data that are measured here are quantitative data. But the difference is in interval, as compared to ordinal, we can give the exact difference, such as body temperature. Now we know that 80 degrees Celsius is higher by 10 units than 70 degrees Celsius centigrade. So it's an interval level. But the difference between ratio and interval is there is no meaningful zero in the interval level. Variables measured in the interval levels are temperature, IQ, and scores. Because when you say IQ, when the IQ of the person is 0 or when the score of the student is 0, it does not mean that there is an absence of intelligence. Kung nag-0 to siya score, meaning nag-0 siya sa test, okay, it doesn't mean that there is an absence of intelligence. Basi wala lang saya katuon. However, you can give the exact difference. When the score of one student is 80 in the exam and the other is 70, then you can describe or you can compare that the score of one student is 10 points higher than the score of the other student. But if you put these values into ratio form, there is no meaning to it.
System activated.
Such as, for example, the temperature outside is 40 degrees outside the room, and the temperature inside the room is 20 degrees. You put it in ratio 40 over 20, it does not mean that the temperature outside is twice as hot as the temperature inside. But when you compare, you can only say that the temperature outside is 20 points or 20 degrees higher than the temperature inside. Or if you compare the scores of the two students, like one is 40 and the other one is 80, it is wrong to conclude that one student is twice as intelligent of the other student. Kay 80 siya, ang isaya is 40, no. When you compare it, because grades are measured in the interval level, just describe how many points higher or how many points lower. Now, in the highest level of measurements where quantitative data are measured here, when you put the data in ratios, you can put meaning to it, like number of children. If one family has 5 children and the other has 10, then it is correct to say that one family has twice the number of children than the other family because it's in the ratio. My meaning, ang 0, if the number of children is 0, then there's an absence, wala sila bata. Pero sa interval, there is no meaningful 0. 0 degrees Celsius or 0 degrees Fahrenheit does not mean an absence of hotness or coldness of the body temperature. It does not mean that there is or the kinetic energy of the molecules in the body is 0, because 0 kinetic energy is only when the temperature is equal to absolute 0 Rankine or absolute 0 Kelvin. That is, of course, but we don't use it when we measure the body temperature. So we measure it in either degree Celsius or in degree Fahrenheit. So again, this is very important because after identifying the variables in the study, you also have to identify its corresponding level of measurement. So if I ask you, for example, number of students in the library, what level of measurement does it belong? Or level of students who are present right now? Ratio, interval, ordinal, or nominal? Okay, so very good, ratio. So ratio na siya because of course when the value is equal to 0, there is an absence of students. May meaning siya ang 0. Next, so since in inferential statistics, you need to collect a sample from the population. There are several types of sampling techniques, and this is divided into 2 groups, probability sampling and non-probability sampling techniques. In a probability sampling technique, the chance of a member in the population to be selected is not equal to 0. There are 5 types of probability sampling techniques under, probability sampling it is random sampling, systematic sampling, stratified, cluster, and multi-cluster sampling. And these are the sampling methods used in quantitative research. In conducting a random sampling method, you should have, or one must have, the complete list of the members of the population, which you call it the sampling frame. There are several ways in conducting this sampling technique. You put the names of the members of the population in a piece of paper, roll it, put it in a fish bowl, and randomly select the samples from the fish bowl, given the sample size. So later I'm going to discuss how to compute for the sample size. Or you may use a randomizer. When you use a randomizer or random numbers, random every member of the population from 1 to n. And you can get a random number from a scientific calculator. So I think there's a function. Click mo lang na siya, get the last digit. That would now be the number corresponding to the member of the population will be selected. That is random sampling, or the Tambiolo method. That's an example of random sampling technique. Systematic sampling, that is when you get every Kate member of the population. When you get every Kate member of the population, now what is the value of K? The value of K is equal to the population size minus the sample size. I'm going to give you an example later how to find for the value of K. This is good, no, if you want to interview, no, every Kate member of the patient entering the hospital, for example, a systematic sampling method. Stratified sampling method, if you are going to draw samples from every strata or every group in the population. Supposing the population is composed of students from the nursing or from the College of Nursing, and you want to every year level will be represented, then you use stratified sampling method. If the composition in the population in the College of Nursing, for example, there are 30% first year, then in the sample, may dapat 30% man. So later I'm going to show you the formula how to find the number of each strata that should be found also in the sample. Next is cluster sampling. Cluster sampling, this is used when the population is very large. For example, your respondents are all nurses in Region 6. So that's a very large population. Employed in a public hospital. You may use cluster sampling, randomly select one of the top hospitals in Region 6, but you must select every member in that hospital or every nurse in that hospital. Supposing hospital A, B, C, and D. Okay, so you randomly select from these 4 hospitals. Napilian mo. So for example, Hospital C. Using cluster sampling, all nurses employed in Hospital C are part of the sample. That is cluster sampling. And multi-cluster sampling, you again, so for example, the hospital is it's a very big hospital. You will randomly select from the different departments in a hospital. Randomly select naman. So you have PEDJA, emergency, and other departments. So multi-cluster sampling technique. That is if the population is very large. If the population is Philippines, nag-cluster ka, you randomly select from the 3 major what do you call this, from Luzon, Visayas, and Mindanao, major islands of the Philippines. Now, for example, you randomly selected Visayas. So it's again, the population is very large. Conduct multi-cluster. You choose the district. No, again, conduct naman how many district does Negros Occidental has. So from that, so that's an example of multi-cluster sampling technique. Non-probability, if the chance of selecting, there is no chance, rather. The probability that every member of the population using non-probability sampling technique is equal to 0. This is used in qualitative research. Convenience sampling. The best example of convenience sampling is Salle survey. So you will just position in one place and whoever, kung sino ang masugatan mo, you will interview that person. So that's convenience sampling technique. Non-probability. Purposive. Purposive is used in qualitative where you will have a criterion. A criteria in selecting the respondents. For example, your research is on the lived experiences of cancer survivors. So what are your criteria in selecting your respondents? So first is, must be a cancer survivor. Another is, for example, limit mo lang siya nga, the respondent must be a female. So kung male siya, may nakita ka being a male cancer survivor, but because you have a selection criteria, then that male cancer survivor will not be invited as part of your research. Quota, if the number of respondents is set, and then snowball if you started with a very small sample size, and then the sample size increases as you get references from your small respondents. Next, this one. There are several formulas for the sample size, but the formula that I will present is by Cochrane, for which the famous, the controversial Slobin formula was derived. So this is the formula for Cochrane. There are two formulas, one wherein if you're going to use mean in your research, or one wherein you will only use the proportions. So as you can see, you have to find the Z value from the Z table. This one is the symbol for sigma. This is the population standard deviation, and E is the maximum error or the margin of error. Now we're going to use, so I sent the PHStat file. So it's the software that I am using. This is just an add-in in Excel. I am using this because this is free. It does not require a license. This was developed. So this is a software as an add-in in Excel. This was developed. PH does not stand for Philippines. PH stands for Prentice Hall, one of the largest publishing company in the US that also, they are also producing statistics books. They hired computer programmers and statisticians to make this software. But the file that I have sent is not already free when you download it online. So I was able to download it before. Siguro na notice ang Prentice Hall that many are using it for free. So right now, if you're going to find this file online, it is not already for free. You have to buy a Prentice Hall textbook before you can get their latest version. So because it's not available, I received several emails coming from different regions and coming from even outside of the Philippines as far as Russia. So there's one who contacted me for this file because the student saw my YouTube tutorial about how to install PHStat. So taga Russia sagli. Because it's free. It's free and it's user-friendly. And once you have installed this, you can process your data using different statistical techniques according to what your research requires. So may I ask here in the from the participants, who among you was able to install the PHStat in Excel successfully? You may drop an approved sign. But anyway, so I have already shared the link and the file. You can install it. It's very easy. There are for two versions. So for 2010, you can install it without having security issues. But for 2016 and above, there's another link where you can install it because there are some security issues that you have to check in your Excel spreadsheet. So let's have this. Supposing the population size in your research is 5,300. So 5,000 is a very large population size. If you're going to use all of the respondents, it will take time. Find the sample size for a population of 5,300 students at 95% confidence interval and 5% margin of error. So these are the three values that you need in computing for the sample size. However, now we will use PH-stat in computing for it. Now, the acceptable values for margin of error is 5% to 8%. For the population standard deviation, if it is a known, you may use 0.5, but you can use a data from the previous study. But again, kung wala siya, if the data is not available, use 0.5. Okay. So if PH-stat is successfully installed in Excel, you will see a ribbon here, add-ins. Then go to PH-stat. Do you see my screen? Do you see my screen? Which is now, I am opening Excel. Okay, so we are now going to compute the sample size given that the population size is 5,300 at 95% confidence interval and 5% margin of error. So when you see this ribbon, it means that PH-stat is successfully installed in Excel. You click PH-stat and click sample size. So if your research requires you, yes.
Doc G,
Yes.
can you try to show us? Maybe we can see only a black screen.
Okay.
As of this time.
Okay, so black screen na lang. Here. Thank you, Doc Shai. How about this?
It's already shown. Yes. Excel file.
So these are the data that we are going to use later as I run the different common statistical tests. So, but for now, as what I've said, how are we going to use PH-stat in computing for the sample size? So when you see this ribbon in in your Excel, it means that PH-stat is already successfully installed in your spreadsheet. So click PH-stat, go to sample size, and click determination for the mean. And we're going to put in the values. If there is no past population standard deviation of in your research, put 0.5 for the sampling error because the problem assigned already a value for the sampling error, which is 5%. The acceptable value for the sampling error is between 5% to 8%. So we'll use 0.05 at 95% confidence interval. And since the population size is given, we click or we tick this box, finite population correction, and input the given population size, which is 5,300. Okay. So the required sample size is 359. So that is the required sample size. Now using the formula of Cochrane with a population standard deviation of 0.5 and the margin of error, which is 5%. Now, so what if the sampling technique that you are going to use in your research is systematic or stratified, given that the sample size is 359? How will you solve the number of respondents from every group, or how will you solve for the value of K? So now that we have already computed for the sample size, which is 359. For systematic sampling, if your research requires you to use systematic sampling, where every K member of the population is selected, to find for the value of K, K is equal to the population size divided by the sample size. So if the population size is 5,300, using the population size I presented in the problem, and then the computed sample size is 359. The value of K is 15. Therefore, you have to select every 15th member of the population, but you randomly start from numbers 1 to 30. If you're using systematic sampling, you must have the complete list of members of the population. You arrange the members either in any form, alphabetical, and then number it from 1 to n. You randomly start not at 1, but from any number between 1 to 30. For example, you randomly start at 20. 20, or the 20th member of the population, is the first sample. 20 plus 15, that would be 35. The 35th sample will be the next sample. That is systematic sampling. Now, for stratified sampling, Doc Shai, is my screen clear? Because what I am seeing here, may mga lines. Doc Shai or Doc Tony? Okay.
There are lines, but I can see under systematic sampling. For stratified, there are lines.
Okay. So for stratified sampling, so if the population, for example, is 300, and this 300 is composed of 180 nurses from the pediatric unit and 120 from the emergency unit. And you need a sample size of 169. So how many samples will be selected from the pediatric unit, and how many samples will be selected from the emergency unit? Let me share again. Okay. So using the stratified sampling technique, using the stratified sampling technique. So if the population or the target population, for example, is 300, and there are 180 nurses from the pediatric unit and 120 nurses from the emergency unit, the sample size required in your research is 169. How many would represent from the pediatric unit and from the emergency unit? So you simply divide the sample or the total population size from the pediatric unit, that's 180, divided by the population size, 180 divided by 300 times the required sample size, which is 169. Thus, it is equal to 101. For the number of nurses that will be selected using random sampling, so when you use stratified, so you randomly select from every strata or from every group in the population. From the emergency unit, the number of nurses that you are going to select is 68. That's equal to 120 divided by the total population size, which is 300 times 169. Are there any questions in finding for the sample size? So as what I've said, it is very helpful if you are going to install PHstat in your Excel. There are also several softwares like SPSS. However, SPSS requires a license, so you have to pay for the license. There is R. R is free, but it's complicated. You have to learn the different what do you call, because it's for programmers, so different programs. It's R, and then there's Jamovi. So, but this one is user friendly. So that ends now my discussion in the first part. We now go to descriptive statistics. So in descriptive statistics, you're going to perform various descriptive analyses, like measures of central tendency and measures of standard deviation. The common statistical treatments that are used in descriptive statistics are frequency count and percentages. Okay, these are commonly used in organizing qualitative data. Data that are measured in the nominal and interval level, such as the profile of the participants according to sex and college, according to educational attainment, religious affiliation, and other qualitative variables. If your research objective requires the participants to answer yes or no, then the statistical treatment that you are going to apply is frequency counts and percentages, or questions that requires multiple responses and Likert data, like rarely, sometimes, often, or as what I've said a while ago, very agree, disagree, and very disagree. So these are Likert data. The statistical tool that you will apply is frequency counts and percentages. Now, we're going to have an exercise, but no, you were not able to install PHStat. So I'm just going to show you how to organize your data using PHStat. So I also share the Stat5 data, and we are going to prepare the profile of the respondents according to the following variables: sex, marital status, and educational statement. I'm going to show you the data. I'm sorry. Okay, so this is an example of data encoded in Excel. As you can see, there are the variables are age, educational level, gender, marital status, smoking status, exercise, weight, serum cholesterol, systolic pressure, IQ, and sodium or sodium concentration. The data are now coded, for which if yes, sir, OJ.
Doc, excuse Doc, your screen is not shared.
Okay, so you could not see my screen.
Earlier, Doc, yes.
Okay, so let me share again. How about this?
Okay na, Doc. Thank you.
Okay, so this is an example now of once you have collected the data, you encode it in Excel. Now these are the variables. For the first column, the values under the first column represents the ID number of the respondents. The second column is the variable age. Third is educational level, then gender, marital status, smoking status, exercise, weight, serum cholesterol, systolic pressure, IQ, and sodium. The profile variables, if you're going to prepare or organize the data according to educational level, gender, and marital status. Educational level is coded as 2 and 1 and 0. What does 0 represent? So if you look at the right side of the sheet, 0 for educational level stands for or represents participants with no high school degree. 1 represents participants with high school degree, 2 for college graduate, and 3 for graduate degree. For gender, F stands for female and M for male. For the marital status, M stands for married, S for single, W for widow, and D for divorce. So there are 4 groups for marital status, while there are also 4 groups for educational level, and for the gender, there are only 2 groups, male and female. Now the question is, if this is your data and the first objective in your research is to present the profile of the respondents according to these variables: gender, marital status, and smoking status. If there is no add-ins in your PH stat, you can do this, okay, one at a time using pivot table. But for PH stat, you can simultaneously find the profile or the profile variables of the respondents according to these three variables. Sorry. Again, educational level, gender, and marital status. Recall that educational level is a qualitative variable measured in the nominal level. Gender is also a qualitative variable measured in the nominal level, and marital status is also a qualitative variable that is measured in the nominal level, for which the statistical treatment that we can only apply are frequency count and percentages. We could not apply mean and standard deviation. There is no such statistical term, average gender, average educational level, or average marital status. But what if we are going to describe the respondents according to these variables, we can describe them according to how many percent of the respondents are female, how many percent are male, or how many are married, widow, single. So let's see. Let's run now statistical tests. How do we find the frequency count and the percentages? First is you have to unstack the data. That's the first. No? So I'm going to share the PowerPoint later if in case you're going to use, unstack, it's not stack the data. If you're going to use PH stat. So in unstacking the data, just simply highlight all these three columns, including the values. Then click OK. So this will put the values into two columns. The first column is the group or the variables, the name of the variables, and the second columns are the values. Then go back to PH stat and go to descriptive statistics and run two-way tables. Row column variable, highlight the first column. Including all the values in the first column. Then for the column variable, highlight the second column, including all the values under it. You must tick this box because we included the labels of the two variables and click OK. So now we see this. So for the educational level, if we go back to sheet number 1, okay, the codes are 0, 1, 2, and 3. So how many are married, or how many have no high school degree? How many have high school are high school graduate? How many are college graduates? So let's go back to this sheet. In the educational level, there are 13, 43, 36, and 8. So 13 represents no high school. So we will just convert this to their descriptive equivalent. For the gender, if you look at this under F, there are 50 female participants and there are 50 male participants. For marital status, if the respondents are grouped according to marital status, there are 16 respondents who are divorced. There are 53 respondents who are married. There are 22 respondents who are single, and there are 9 respondents who are widow. These values represents the frequency counts. How are we going to convert this into percent? If you do it manually, it's okay because the total population size is 100. You simply convert this to percent, that's 13 divided by 100 times 100. 13 divided by the population size times 100. Or you may go to this box, the pivot table field list, drag value under the summation of values. Okay, go to value field settings and then show values as percent of the row total. Okay, that's it. 13 as frequency count is equivalent to 13%. 43 represents 43%. Now, if you are going to present your result, you don't, it is wrong to copy and paste or cut and paste. So there is a format in presenting the profile of the participants. And what is that format? So here is an example in presenting the format of the participants, or rather the profile of the participants. So after organizing and getting the profile of the participants according to the variables like educational level, gender, and then marital status. So this is an example now of the profile of the respondents. So however, so this one is the profile of the respondents. This is taken from the data of one of my colleagues who is conducting a study on the carousel instruction. Carousel type of online instruction. Carousel, so it is categorized into two groups, majority and mixed. The total number of respondents is 253. So as you can see, this is the frequency count, the third column, and the fourth column is the percentage. Then in the second column, you put the category. If the respondents are grouped according to year level, then there are first year, second year, and then third year. Then according to degree, so BA in IDS, BA in psychology, in political science, BS Bio, communication, and LIACOM. So this is how you present your or the profile of the respondents. You use the APA format. In the APA format, there are only 3 horizontal lines. There are no borders, there are no vertical lines. Tatlo gid lang ka lines, and you put tables. So if this is the first table that you are going to show in your results, then that would be table 1. Question in presenting the profile of the respondents. So again, if the first question in your research is the profile of the respondents, the statistical treatment is frequency count and percentages only. Next, when do you use mean and standard deviation as a statistical tool in processing your data? You use mean and standard deviation for interval and ratio data. So as what I've said, if the data is measured in the nominal or in the ordinal level, you are only limited to frequency count and percentages. There is no such statistical term as mean marital status, as mean educational level, but percent of the respondents who are married, percent of the respondents are female, or rather who are female. But for mean and standard deviation, we use this for interval and ratio data. In some cases, we take the mean if the data are Likert, because there are 2 schools of thoughts. So there are statisticians who belong to the old school of thought, or for non-parametric side and parametric side. So if the distribution of the Likert data is normal and the variable that is being measured have or has subscales or domains, you may take the mean and standard deviation, like attitudes. So if you're going to measure the attitudes of nursing students towards a particular subject, there is a construct for attitudes, and attitudes have several domains, and the responses are Likert responses. The degree of the level of agreement on the every statement of the instrument. So you may consider it, you may count the percentage who answered agree, who answered disagree. But in some cases, if the distribution is normal and if there are several domains, you may apply the mean and standard deviation. If you use the long method, you get the mean by taking the sum and divide it by the number of observations. But if the sample size is 100, that would take time. So again, we are going to use PH-stat in finding the mean and standard deviation. What are examples of interval and ratio variables for which we can apply the mean and standard deviation? Mean is a measure of central tendency. It is a specific value for which most of the data are found. Standard deviation is a measure of the spread of the data, the average difference of the data from the mean in the distribution. The higher the standard deviation is, the more that the values are away from the mean in the distribution. Mean and standard deviation, do mag-asawa na sila. When you report the mean, you also have to report the standard deviation, because if there are two the same mean values, and when you compare it, you further use the standard deviation. Lesser or smaller value of standard deviation means the values are consistent, the values are close to the mean. So this are examples of interval and ratio variables. Academic performance of nursing students in anatomy using their midterm grades. Serum cholesterol. So if your research requires you to measure the serum cholesterol of the participants in the population or members in the sample, you can get the mean and standard deviation. Systolic pressure, level of nursing competency skills, parents' level of awareness, students' level of involvement, and patients' body temperatures. So again, as what I've said, the levels of measurements is very important. You have to, after identifying whether the variable is qualitative or quantitative, the next step is to identify the level of measurement so that you can find the appropriate statistical treatment to it. So for this, if you want to measure these variables, these are interval and ratio variables, then use mean and standard deviation. So I'm going to show you again how to find the mean weight of the values. Now I presented the mean serum cholesterol and the mean systolic pressure. So you just simply run the descriptive statistics using PH-stat. We will go back to the file. So can you see the Excel data in your screen? Okay, so we will go back to the original data. So we're going to find the mean weight. So meaning if the objective is to find the mean weight, mean serum cholesterol, mean systolic pressure. So how do we use PH-stat? Though in Excel, you can also find the mean. So there's a formula, you may search it, but that would take time because you're going to do it column per column. You find the mean of every column here. So when we are going to take the mean of these three quantitative variables simultaneously, you go to descriptive statistics and choose descriptive summary. Then instead of single, choose multiple groups and stacked. So because we are not only finding one mean, but the mean of three quantitative variables. Then highlight these three columns containing the values of weight, serum cholesterol, and systolic pressure. Click OK. This is the result now. So this is the complete descriptive statistics. The mean weight of the respondents is 150.03. The mean serum cholesterol is 214.91. The mean systolic pressure is 130.95. So if your research further requires you to find the median, these are the median values, the mode, the minimum value. 99 means the lowest weight value, 164 is the lowest serum cholesterol, 110 means the lowest systolic pressure value. Maximum value is 234 underweight, 288 under serum cholesterol, and systolic pressure. Variance, so you also have the standard deviation. So these are the two values that you need in reporting your results. So for example, your research objective is what is the mean weight of the respondent. So get the mean and the standard deviation. Now, do not copy this and paste in the results of your research. This will be placed under the appendices. So you will just get these values. And if you want to know the shape of the distribution, you can consider the values of the skewness and the kurtosis. If the distribution is normal, the skewness must be close to 0. If it is not normal, if it's positively skewed, the value is positive. If it's negatively skewed, the value of skewness is negative. Count means the sample size or the number of values. So 100, there are 100 respondents. So count represents the number of values that you have used in processing the data. But how do you how do you report these results? Because as what I've said, hindi na siya pag i-copy, kag i-paste, amo na siya din ang results sa inyong thesis. So when you report these results, you must also use the APA format. This is an example of showing the results after finding the mean and the standard deviation. Okay, so it contains 4 columns. The first column is the variable. So this is an example where mean and standard deviation are used. So I did not include the standard deviation, but you have to add the standard deviation and also the sample size. Now for this, we have the level of awareness when grouped according to sex. For the female respondents, the computed mean in terms of the level of awareness is 4.34. For the male group, it's 4.21. Excuse me. Now, how do you interpret this? Well, since in this example, the data are Likert data, the respondents would choose based on the 4 responses: extremely aware, very aware, moderately aware, slightly aware, and not at all aware. Now, to prepare the interpretation scale, so the table that you see at the right is the interpretation scale for the mean range. If the highest value is 5, which represents an extremely aware response, I know most of you here have already experienced answering a research questionnaire. So choose 5 if you feel that your answer is extremely aware. Choose 1 if you are not at all aware. But since the statistical treatment that you use is the mean and standard deviation, you have to interpret the mean. So how do you prepare this? So you prepare this by getting the difference of the highest response, which is 5, minus the lowest response, which is 1. 5 minus 1 is 4, and divide it by the number of levels. So 1, 2, 3, 4, 5. So 5 minus 1 is 4 divided by 5. So 4 divided by 5. That would now be, so that would be, you prepare it, so 1 plus 0.8, that would be the first, 0.81, then plus 0.81, so 2.61, 3.41, and 4.21. So as a researcher, you work with the statistician and prepare the table of interpretation for the mean, such as this. The mean is 4.34. What is the interpretation basing on this interpretation scale? You may write your answer in the chat box. Is it not at all aware, slightly aware, moderately aware, very aware, or extremely aware, since the computed mean is 4.34. Yes, correct. Extremely aware. Then for a mean of 4.21, so again, it's extremely aware because 4.34 falls within the range of 4.21 and 5. For 4.21, the answer is also extremely aware. Very good, because 4.21 is within the range 4.21 and 5. But what if the computed mean is 2.5? What is the interpretation? If the computed mean is 2.5. Send your answer in the chat box. Yes, so you are correct, slightly aware. So that would be your corresponding interpretation. So I repeat, you must prepare this also for the interpretation of the mean. So in order, when in the discussion, it would be the mean would be interpreted based on the context of the research. So mean represents as the level of awareness of the respondents that when mean is 4.34, it is interpreted as extremely aware. When the mean is 4.21, it is interpreted also as extremely aware. When the mean, for example, is 3.5, it is interpreted as very aware, or the respondents' level of awareness is very aware towards online classes, for example. Next. Oh, so we are done with the second part of this webinar, which is about descriptive statistics. We now go to the third part, which is inferential statistics. There are three types of analysis in inferential statistics. We have hypothesis testing, predictive analysis, and regression analysis. What we will have is hypothesis testing. Now, in hypothesis testing is a decision-making process in drawing a conclusion for a population. You select a sample, you take the data from the sample, perform descriptive analysis and inferential analysis, draw a conclusion, and your conclusion is for the population. So that is inferential statistics. Okay. So in hypothesis testing, the first step is to give the null and the alternative hypothesis. When you say hypothesis, this is your claim about the population. The null hypothesis claims that there is no significant difference between the two observed values or two or more observed values. The alternative hypothesis claims that there is a difference, or the medication, for example, the intervention program, okay, that you want to test is effective or not. I repeat, kung nag-test ka for a medication program, an intervention program, the statement of the null hypothesis is the program is not effective, or there is no difference between the two observed or two or more observed values. Alternative hypothesis, there is a significant difference or the product is effective. The vaccine is effective. That is the statement of the alternative hypothesis. We are going to perform a test. Why do we need to perform hypothesis testing? Because the data is taken from a sample. What if the data is taken from the population? Then there is no need to conduct hypothesis testing. There is no need to conduct if the data is taken from the population. But if you are going to use a sample, you are going to collect the data from a sample, you have to perform hypothesis testing. There are two common methods for hypothesis testing, the traditional method and the p-value method. In the traditional method, you use a critical value and compare it with a test statistic. In the p-value method, this is the value that is generated by statistical software because this is the actual probability of committing an error that you rejected the null hypothesis even if it is true. So because there is no perfect research. So we have to consider the probability of committing this error. Rejecting the null hypothesis, you reported that the vaccine is effective even if it is not true. That's type 1. Type 1 error. There are two types of error in hypothesis testing, type 1 and the type 2 error. What is good in PHStat is it uses these two types of method, the traditional and the p-value method. In the traditional method, you have to find the statistical test value and compare it with the critical value. So this critical value is taken from the table. That divides the area under the normal curve into two, the critical region and the non-critical region. That is, if the test value falls in the critical region, in the shaded area found on the right and the left side of the curve. If the test value falls in the critical region, the decision of the test is to reject the null hypothesis. Rejecting the null hypothesis means that there is a significant difference in the two values. Failing to reject the null hypothesis, that is, if the statistical test value falls in the non-critical, so the unshaded area is known as the non-critical region. So if it falls here, then you fail to reject the null hypothesis. The critical value in there are two critical values because the test is two-tailed. So a test could be right-tailed, left-tailed, but most, the direction in actual research, the test that is used is two-tailed. The critical value in this test is positive 1.96 and negative 1.96. Supposing the test that is used is t-test, and the test or the computed t-value is 1.98. The critical values are 1.96 and negative 1.96. The computed t-value is 1.98. What is the decision of the test? Reject the null hypothesis or do not reject the null hypothesis? Okay. Put your answer in the chat box. So as what I've said, if the test value is 1.98 and the critical value is 1.96, what is the decision of the test? Or first, okay, ang imo nga test value falls in what region? Critical region or non-critical region? Look at the illustration and give me your answer in the chat box. Where can you find, first, where can you find the test value if the test value is 1.98? Is it found in the critical region or non-critical region? 1.98. Yes, correct, no? It's in the critical region. Next question. What is the decision of the test? Reject the null hypothesis or do not reject the null hypothesis because the test value falls in the critical region. Yes, you are correct. Reject the null hypothesis because it falls. No, this is the rejection area. But if the test value, for example, is 1.3, then the decision is do not reject or fails to reject the null hypothesis. So if the test, the decision of the test is not to reject the null hypothesis, therefore there is no significant difference. If the decision of the test is to reject the null hypothesis, therefore there is a significant difference between the two values. The decision rule for using the p-value method, the p-value is compared to the level of significance. So if the p-value is less than the level of significance, which is denoted by alpha, level of significance is the probability of committing type 1 error. So it's rejecting the null hypothesis even if it is true. So you reject, the decision is then reject the null hypothesis. If the p-value is greater than alpha, so the decision is fail to reject the null hypothesis. Now, so what type of statistical test do we use for when we conduct hypothesis testing? There are two types of tests, parametric tests and non-parametric tests. Parametric tests are used if the following assumptions are met. The data must be interval or ratio. The distribution of the data is approximately normal. The data is independently and randomly selected from the population, and parametric tests are more robust than non-parametric tests, and parametric tests are powerful than parametric tests. So it is more powerful in detecting the effect or the difference between the observed values. Non-parametric tests are used over parametric tests if the data is either nominal or ordinal, and the distribution is not normal if the distribution is either positively skewed or negatively skewed. So we use non-parametric tests. So what are these parametric and non-parametric tests? Now, for the test of difference in means, supposing you want to compare the academic performance of the students if they are grouped according to sex. So grouping the students according to sex, there will be two groups, male and female. You want to know who performed better. Is it the group of female students or the male students? You conduct this test of difference in mean. There are 4 common statistical treatment t-tests for independent samples. If you want to compare the means of the two groups for which the two groups are independent, t-test for dependent or related samples if the two groups are related, one-way ANOVA if you want to compare the sample means for 3 or more groups, two-way ANOVA if there are 2 or more independent variables. Now, if the distribution is not normal and if the values or the data are measured in the interval and the nominal level, you have to use its corresponding non-parametric test. So we call it test of difference in medians. The counterpart of t-test for independent samples in non-parametric tests is called Wilcoxon rank sum test or Mann-Whitney. The counterpart of t-test for dependent or related samples in non-parametric tests is signed rank test. For one-way ANOVA, it's Kruskal-Wallis. There is no counterpart for two-way ANOVA. Two-way ANOVA is commonly used in experimental research. So if there are 2 or 3, 2 or more independent variables. So let's start now, independent. So when do we know that the samples or the groups are independent? So therefore, if the groups are not related, for example, group of students from La Salle and a group of students from San Agustin, nurses from one department from the pediatric group and nurses from the emergency group. These are 2 independent groups. The samples or the group are related if you use the same set of samples before and after. This is used for t-test for dependent samples if you want to know if an intervention program is effective or not. You give the pre-test, then you give the post-test after intervention. Or if the samples are paired, like you will divide the twins into 2 separate groups, or your respondents are married couples. So that would fall under related samples. Take note that t-tests for independent samples and t-tests for dependent samples are only used if you want to determine if the difference observed is significant or not for 2 samples. But if there are 3 samples, you could not use these 2. You have to use one-way ANOVA. If the groups, for example, or if the respondents are grouped according to year level, and there are 4 year levels, first year, second year, third year, and fourth year, t-test would not be applicable. You have to use one-way ANOVA. Test of relationship. So these common statistical test, parametric test to test if the relationship between two variables are significant or not, Pearson correlation, but it must show a linear trend in the scatter plot. If the scatter plot of the values does not show a linear trend, you could not apply the Pearson correlation. But if the relationship is monotonic, nag-curve siya that as X or the values or the independent variable, the independent values increases, Y increases also, use the Spearman correlation, you have to rank the values. If this type of tests are used if the data are interval or ratio, but if the data are nominal or ordinal, you must use its counterpart under the non-parametric test, which is chi-square test of independence, getting if you want to determine if the relationship between nominal or interval variables are significant or not. Or you may use the Mac-Niemeyer test for dichotomous variables, for nominal and interval variables with two responses like yes or no for the gender, male and female. So if you want to know if gender is related to the responses of the participants, you may use the Mac-Niemeyer test. So you use the t-test for two independent samples if this is, for example, the research-specific objective. Is there a significant difference in the mean systolic pressure when the participants are grouped according to sex and level of exercise? So the grouping variable is sex and the level of exercise. However, for the level of exercise, no, there are three. So we could not use, we could not use the t-test, we will use the ANOVA. But for sex, there are two groups, male and female. So we use t-test. Now, you have to state the null hypothesis and the alternative hypothesis. If this is the research SOP, then the null hypothesis would be there is no significant difference in the mean systolic pressure when the participants are grouped according to sex and level of exercise. The alternative hypothesis would be the opposite. There is a significant difference in the mean systolic pressure when the participants are grouped according to these variables. Okay. When do we use the t-test? So we use the t-test. Now I'm showing two examples. If the t-test for paired samples will be applied. So here, there is a pre-test before and after because an intervention was introduced to a group of students here. These values here represents the number of hours each student studied per week before and after the seminar, and that seminar would improve the study habits of the students. To determine if the seminar is effective in improving the study habits of the students, the applicable statistical test is t-test for paired samples. Here is another example where you need to apply the t-test. Now comparing the mean pulse rate of twins. Twin A and then twin B, separate sila, ginkuhaan sila sang pulse rate. Then compare if there is a difference or significant difference in the mean beats, number of beats per minute or average pulse rate. I'm going to show you how to run the t-test and the pH-TAT. Okay, so this is the original data. We are going to check if there is a significant difference in the weight of the respondents. For example, when they are grouped according to sex or gender. When they are grouped according to gender, there will be two independent groups. The group of weight values for female and the group of weight values for male. So how are we going to separate the values or the weight of female respondents and the weight of male respondents. So because this, as you can see, ang data wala pa na organize, no, into two groups. So we go back to add-ins, choose PH stat and go to data preparation. Unstack the data. Unstacking the data means it will separate the weight values to female and male. The grouping variables would be the gender, since you will group the weight values into male and female, while the row or the stack data cell range are the values under the weight. Let's see if there is a difference in the mean weights of the two groups. So this is now the group of, or the weights of female respondents and the weights of male respondents. And these two groups are two independent groups. They are not related. Now we are going to apply the t-test. Go to PH stat, choose two sample tests. There are two types of t-tests for independent samples. T-test if the variances are equal, if the variances of the two groups are equal, and the t-test if the variances of the two groups are not equal. How do we know if the variances are equal? So you just check the computed standard deviation, or you may apply the Levine test. So, but rule of thumb, if the standard deviation of one group is twice as much as the standard deviation of the other group, then the variances are not equal. You have to run or rerun the test, because pooled variant t-test is t-test for equal variances, and separate variant t-test or variance t-test is t-test if the variances of the two groups are not equal. Let's choose pooled variance t-test, assuming that the variances of the two groups are equal. The hypothesized difference, since we stated in the null hypothesis that there is no significant difference in the mean weight. So when there is no significant difference, it means that the hypothesized difference is 0. Population sample cell range is the values of the weights under the female group, and population to sample cell range just simply highlight the values in the let's repeat. Let's go back here. Population to sample cell range. Highlight the second column, or the weights of the male group. Oh, sorry. Here. Let me repeat the process again. Nadula ang akon nga data. Okay. So, run the t-test, choose pooled variant t-test, assuming that the variances of the two groups are equal. Highlight the first column. Then highlight the second column. Choose two-tailed test or two-tailed test. In actual research, the test that is commonly used is two-tailed test. And the level of significance that is commonly used is 0.05. So here is the output. And this is not the one that you are going to show in the results of the study. You will just extract the mean, the standard deviation, and the results of the test. What is good in PH stat, it shows both, using the traditional method and the p-value method. Recall that population 1 represents the group of female weights, and population 2 represents the weight weights of the male group. The sample size of the female group is 50. The sample size of the male group is 50 also. The sample mean, the mean weight, so the variable we considered in this test is weight. Now, weight is a ratio variable. So sample mean for the female group is 129.68. The sample mean for the male group is 170.38. There is a difference, 170 versus 129. What is the difference? If we take the difference, that is 40. Is that difference observed significant or not? Because if the difference observed is not significant, then it is only due to chance. We can therefore conclude that there is no significant difference even if the computed sample, take note, the data are taken from the sample, not from the population. So since the data are taken from the sample, if the test tells us that there is no significant difference, the difference observed is due to chance only. And you could not conclude that in the population, there is a significant difference. But look at the decision here. The value of the t-test is negative 9.31. The critical value is 1.9 and negative 1.9845 and negative 1.9845. Using the traditional value, this value, which is negative 9.316, falls in the critical region, in the rejection region. Using the p-value method, 0 is an acceptable value. It is less than the level of significance, which is 0.05. Thus, the decision of the test is to reject the null hypothesis. So what is good in PHStat? You are not going to go back to your notes. What is ang ganing decision if the p-value is less than the level of the significance, or the t-value is greater than the critical value, because it tells you a decision. You will now interpret in the context of your study. Rejecting the null hypothesis means what? Is there a difference, or is there is no significant difference? So if you are to interpret the result, reject the null hypothesis, the decision. So we are finding out if there is a significant difference between the mean weights of female and male respondents. How do you interpret this result if the decision of the test is to reject the null hypothesis? Is there a significant difference or no significant difference? Write your answer in the chat box. Rejecting the null hypothesis. Does it mean that the difference in the observed sample mean is significant or not? Reject the null hypothesis. Only one sent me the answer. Oh, there's another one. Okay, correct. There is a significant difference. The difference observed between 170 and 129 is significant, which implies that female respondents are heavier than male respondents. But if the decision of the test is not to reject the null hypothesis, this observed means is not significant. They have the same means. This result will only tell you that it is due to chance only. But look at, as you can see, the decision reject, then the difference is significant. Very good. Thank you very much for your answer. So that's how you interpret the test. Now for the pair t-test, how do you run the pair t-test? So these are now the values now I presented in the first problem, where you are required to use the pair t-test to test if the program or if the seminar could improve the study habits of the students. So run. By the way, let's go back to, let me go back. So compare first the standard deviation. The standard deviation is 20 for female and for male is 23. So there is a small difference in the standard deviation, which means the variances of the two groups are can be assumed as equal. But if, for example, the standard deviation in one group is 20 and in the other group is 40, you have to run the t-test and choose a separate variance t-test because the variances could not be assumed equal. Let's run this using the paired t-test to check if the program is effective in improving the study habits of the students. Here is the paired t-test. Hypothesized difference, since the null hypothesis states that there is no significant difference in the study, or what's this, the number of hours. Here, these values are the number of hours students spent in studying. So population sample 1 is before, population sample 2 is after. Use the two-tailed test. Click OK. The decision is to reject the null hypothesis. Rejecting the null hypothesis means what? Is the seminar effective in improving the study habits of the students? What is your answer? What would be your interpretation here? Is it effective or not? Because in the problem I gave you a while ago, we are going to test if the program, which is a seminar, the students attended the seminar on the purpose that it will improve their study habits. So a pre-test was conducted, and after the seminar, a post-test was conducted. So with this result, rejecting the null hypothesis. The null hypothesis is there is no significant difference before and after. The alternative hypothesis is there is no significant difference before and after. The decision of the test using t-test for paired sample is reject the null hypothesis. Rejecting the null hypothesis means that, okay, there's only one who sent me the answer. Okay, very good. Therefore, the program is effective in improving the study habits of the students. Are there any questions in using the t-test? So let's go back. Let me continue. Okay, so now the results that you see in PHStat again, it will not be shown under results and discussion in your research. You only have to get the important values. This PHStat output will be placed in the appendices. You are going to use again the APA format, and what are the values that you are going to get from the output. So here is the t-test for results in conducting a t-test for difference in the level of awareness when grouped according to sex. So female and male, the mean is 4.34. The mean for male is 4.21. The sample size is 218. For the second group is 8. It doesn't matter if the sample size are not equal. You can still use the t-test. The t-test is 0.7764, so you have to take the t-test also, or the test value. The critical value is positive and negative 1.9702. The p-value is 4.383. Compare this to the level of significance used, which is 0.05. Therefore, the difference, because the decision is do not reject the null hypothesis. Why? Because the t-test falls in the non-critical region, or the p-value is greater than 0.05. Thus, the difference between the two sample means is not significant. The level of awareness, therefore, between female and male respondents are not significant. The observed difference is due to chance only. Question? Are there any questions? Let's proceed. Now, so recall, no? One-way ANOVA is another parametric test. If you want to test if the difference observed between 3 or more sample means is significant or not. This is if there is only one independent variable, such as this. Is there a significant difference in the mean weight when grouped according to the level of exercise? When the respondents are grouped according to the level of exercise, there will be 4 groups. In the coded data, in Excel, 0 represents none, meaning the respondents are not doing any form of exercise. 1 means the respondents are doing light exercise, 2 moderate, and 3 heavy. So how do we run this in PHStat? So to perform ANOVA, now our grouping variable is level of exercise. So we will use the same quantitative variable. Let us see if there is a difference, because study shows that when you perform exercises or different exercises, your weight is lower compared to those who are not performing any form of exercises. So let's check for this 100 respondents. First, unstack the data. Groupings would be the level of exercise, and then stack data cell range would be the weights of the respondents. Okay, so these are now the 4 groups. Then run one-way ANOVA. So in running one-way ANOVA is under multiple sample test. Choose one-way ANOVA. Then highlight all the values under the 4 groups and click OK. Okay, so it requires a Q statistic that is readily available also in Google. You click this OK, but before you supply this in this cell, go to the ANOVA table and check first if the difference in the means are significant. So if we look at the p-value, the p-value is 0.5429. This is greater than 0.05. The other name for one-way ANOVA is F-test. So the F value is 0.71, the critical value is 2.6. So which means that the F value falls in the non-critical region. So in one-way ANOVA, it does not indicate the decision. You will be the one to make the decision. What is the decision here? Since if we are going to use the p-value, it is less than the level of significance, which is 0.05. So write your answer in the chat box. Reject or do not reject the null hypothesis. Look at the p-value. What is the decision? Reject or do not reject? So that we can make our conclusion for this. We can say that the differences among the weights when the respondents are grouped according to exercise level. Reject or do not reject, because the other term for the mean is average. So these are the mean weights of the respondents when they are grouped according to exercise level. So what's the decision of the test here? Reject or do not reject? Let's look at the p-value. It's 0.5429. Compare it to the level of significance. What would be your decision here? Okay, correct. So the decision is to, is it reject? 0.5429. 0.5429 is less than 0.0. It's greater than 0.05. So if it is greater than 0.05, you are correct, no? Denmark, Sean, you are correct. Do not reject the null hypothesis. So since it is greater than, but if the value is less than, you are going to reject. So do not reject. Failing to reject the null hypothesis means that the difference observed in the mean weights among the groups 150, 152, 153, 137 is not significant. So meaning weight is not, the exercise is not effective. Rather, no, is has no effect. If we are going to look at this, no, after, for example, no, so meaning there is no significant difference if they are grouped according to exercise level, because the decision of this one-way ANOVA is not to reject the null hypothesis. But if the test tells you to reject the null hypothesis, there's a continuation of the test, which is called the post hoc test. So post hoc test that is used here is the 2K Kramer. You have to get this from the 2K Kramer table. Just search 2K Kramer critical value, put it here because it will tell you if the mean. So it will do a pairwise comparison between two sample means and will tell if the means are different or not. But in this case here, you would rather consult the statistician para you will be guided to conduct the post hoc test. So that's all for the test of difference. We will now go to the test of difference. For the test of difference, a rather test of relationship. This is an example of a table showing the results of one-way ANOVA. You have to show the means of the different group. You have to show the F value, the critical value, and the P value. As in this case here, the computed P value is less than 0.001. So which means that the difference observed in the means here is significant. And the highest mean is 4.50 in terms of the level of awareness. The respondents in this example are parents. So in terms of the level of awareness, using the post hoc test, using 2K Kramer, it shows that self-employed parents have significantly higher level of awareness than unemployed parents. And employed parents have significantly higher level of awareness than unemployed parents also, using the means in terms of level of awareness, using the post hoc test. So if, again, the result of one-way ANOVA tells that there is a significant difference, there is a continuation in the test, and that is called post hoc test. Next, we will now go to test of relationship. So test of relationship is done if you want to know if there's a significant relationship between two variables. But you have to determine first whether the variables are interval or ratio, nominal or ordinal. Because if the data are interval or ratio, then you have to use the Pearson correlation. If the data are nominal or ordinal, you have to use the chi-square test of independence. Let's have this. Is there a significant relation? If this is, for example, the specific objective, you want to know if there is a relationship between weight and serum cholesterol. Weight is a quantitative variable. So what do you think? What type of test shall we apply here? Pearson or chi-square test of independence? Write your answer on the chat box. I received one from Miss Julia. Her answer is Pearson. Miss Julia, you are correct. Now, since the two variables that we want to check if the two variables are related, weight and serum cholesterol. Why? Since weight is a ratio variable and serum cholesterol is also a ratio variable. Thus, the statistical test that is to be used here to determine if the relationship is significant between these two is Pearson correlation. But in the Pearson correlation, you have to identify what is the independent and the dependent variable. X represents the independent variable and Y represents the dependent variable. For these two, what can you control? Since X, the independent variable, is the control variable. What can you control? Weight or serum cholesterol? So, which is easy to control? So, is it easy to control the serum cholesterol? Yes, it is the weight. So in this case, we're going to consider weight as the independent variable and the dependent variable is y. So later we're going to run the Pearson correlation. In the Pearson correlation, we will find the value of Pearson R. Pearson R, or the Pearson product moment of correlation coefficient, that tells us the strength of the relationship. Now, if there is a relationship of the variables, you must describe the strength of the relationship, whether there is a positive, the direction first. In terms of the direction, it could either be positive or negative. When the relationship is positive, it means that when weight increases, serum cholesterol increases also. If the relationship is negative, when weight increases, serum cholesterol decreases. That's negative relationship. In terms of the strength, the values of R is in between -1 to +1. If the value of R is close to +1, there is a strong relationship between weight and serum cholesterol. If the value of R is close to 0, there is a weak relationship between the two variables. Now, let's look at the second question. The variables that we want to know if the relationship is significant or not is smoking status and level of exercise. Recall that in the data I presented, the smoking status is converted to 3 groups. 0, 1, 2. 0 means the respondent does not smoke. 1, the respondent smoke 1 pack per day, and 2, the respondent smokes more than 1 pack. For the level of exercise, so it is also converted to 4 categories. So to test the relationship between the two, since smoking status is categorized as nominal data and the level of exercise is categorized as nominal also, we could not apply the Pearson correlation, but the appropriate test is chi-square test of independence, since the two variables are measured in the nominal level. So do not, so supposing i-force mo gid siya. So how will you force this? Because these are the values, smoking status and level are nominal data. When the data are nominal or ordinal, you are not, or you could not use the Pearson correlation. Now, let me show you the, let's go back to the data again. So let us check how do we run the Pearson product moment of correlation and interpret the result. So let us see if there is a difference between weight and serum cholesterol. For the weight, go to add-ins. Pearson correlation is under regression analysis. So choose regression and then choose simple linear regression. Y variable or the dependent variable is serum cholesterol. So highlight this column or the serum cholesterol column. The independent variable is the weight. So highlight the weight column. Use 95. The common level of or confidence level for regression coefficients is 95%. Take regression statistics table, ANOVA, scatter plot. Okay, so here is the value of R. This is the Pearson product moment of correlation. This is the one that you are going to report. However, you have to check because R is the coefficient in the sample. Can you use this to describe the relationship in the population? So you have to perform a test if R is significant in the population. Because this is small letter R. The values are taken from the sample. And you have to perform a hypothesis testing to if you can use this R in the population. So these are now the results. Just look at the p-value. This is the p-value underweight, which is less than 0.05. 0.0038 is less than 0.05. It means that this is this R is significant. We can use this to describe the relationship between the two variables in the population. If the test is not conducted, this small r is only used to describe the relationship in the sample. But an ANOVA test was conducted where P, here is the p-value, which is less than 0.05. This means that there is a relationship between weight and serum cholesterol. And since the value of R is positive, the direction is positive. It means that as weight increases, the amount of serum cholesterol in the body increases also. However, tends to increase. Correlation here does not imply causation. It does not imply that the main cause of the increase in the serum cholesterol is weight. So it does not imply causation. There is only a pattern. That's why the term here tends to increase, not that it is the cause. Now, the relationship, if we are going to describe the strength of the relationship between the two variables, weight and serum cholesterol, is 0.2870. It is close. If it's close to 0.5, then the relationship is moderate. If it's close to 0, the relationship is weak. So this is close to 0.5. So we can say that there is a moderate positive relationship between what variables? So recall ang variables to are weight and serum cholesterol. That as weight increases, serum cholesterol tends to increase also. Question on using the Pearson correlation. So again, so that would be under, if you're going to use page stat, that would be under multiple regression analysis. So choose simple linear regression, and the value of R is the multiple R. Interpret R in terms of the direction. Since it's positive, then since the sign is positive, then the relationship is positive. How about the strength? The strength is moderate. What if the value of R is negative? Say, for example, R is equal to negative 0.90. First, what is the direction of the relationship? Describe the relationship is if R is equal to negative 0.90 in terms of the direction and the strength. Write your answer in the chat box. What if the computed Pearson R is negative 0.90? How do you interpret it? And if R is significant? Because this is interpreted as positive 0.2870 is interpreted as positive moderate correlation between weight and serum cholesterol. What if R is negative 0.90? Yes, so it's negative 0.90. The range of values of R is from negative 1 to positive 1. If R is equal to 1, there is a perfect correlation, positive. If R is equal to negative 1, there is a perfect negative correlation. Negative 0.9 is close to negative 1. So this is interpreted as negative. Your answer is opposite. This is close to negative 0.1. Negative 1, I'm sorry. So it is negative strong relationship. Kay lapit siya sa negative 1. Pero kung negative 0.2, for example, then it's negative weak correlation. This one is negative. There is a strong negative relationship between the two variables because it's close to negative 1. Question at this point? So, dali na lang ta. Okay. For the chi-square test of independence, you have to arrange the data into contingency table. I'm not going to show you. No? Anyway, I have also a YouTube channel. I'm not promoting it. My YouTube channel is exclusive, is for my students. However, it's public also. So you can search for that and check how you will perform this common statistical test in PHStat. So create the contingency table using PHStat, and then you have to run the chi-square test. But here is the interpretation table for the Pearson R's. As what I've said, if it's close to 1, that would be very high positive relationship, moderate, low, and negligible. But if the test that is used is chi-square test, you have to use the chi-square value. If the test shows that there is a significant relationship between the two nominal variables or two interval variables, you have to find the Kramer's V to describe also the association or correlation. The Kramer's V is this. You can also search this in Google and interpret the association, whether it is very strong, relatively strong, moderate, weak, or negligible. Okay, so this is my last exercise, and this is the last part of my presentation. So to check if you have learned something from this presentation, you just send your answer in the chat box. Give the statistical tool that will be used in answering each objective. Number 1, is there a significant difference in the mean body temperature when grouped according to sex? What statistical tool will be used to answer this objective? Is there a significant difference in the mean body temperature when grouped according to sex? Is it t-test for independent samples, t-test for paired samples, one-way ANOVA, Pearson correlation, chi-square test of independence, Spearman correlation? I'll be waiting for your answer before I go to number 2. What appropriate statistical tool should you use if you will answer this specific objective? First, temperature. So temperature is an interval data. You will group the values into sex. So there are 2 possible groups only, female and male groups. Only one sent the answer. Miss Christine, you are correct. Independent sample t-test. Miss Julia, you are also correct. Romeo, you are also correct. T-test for independent samples. Next. Is there a significant difference in the mean systolic pressure of the participants before and after the weight loss program? What type of statistical tool or test should you use if you will answer this objective? Yes, Miss Julia, you are correct. T-test for paired samples. Next, number 3. Is there a significant relationship between marital status and smoking status? Marital status is a nominal variable. Smoking status is also a nominal variable. Okay, so Miss Julia, you are again correct. The answer is chi-square test of independence. Christine, correct. Sean, you are also correct. Next, is there a significant relationship between the body's systolic pressure and sodium concentration? Systolic pressure is expressed in millimeters mercury, and sodium concentration is expressed in grams per deciliter. Again, Julia, very active si Julia. So you are correct. It's Pearson R or Pearson correlation. Next, what is the level of competency skills of nurses when taken as a whole and when grouped according to sex? What is the level? So you want to know the level of competency skills. Glenn, your answer is incomplete. It should be, kulang inyong answer, Glenn and Romeo. Parisay na sila per me. You have to find, yes, Antheris and Glenn, you're correct, mean and standard deviation so that you can describe the level of competency skills of the nurses. Correct. Next. Last. What is the profile of the respondents according to sex and family income? What statistic? Yes, correct, Julia. Frequency and percentage, or frequency counts and percentages. So this ends my presentation, and I would like to leave you this quote from the father of statistics, Ronald Fisher: "To consult the statistician after an experiment is finished is often merely to ask him to conduct a post-mortem examination. He can perhaps say what the experiment died of." So this is just telling you that when you start with your research, you have to consult the statistician with regards to the variables in the study, with regards to the sampling techniques, and with regards to the other section in your research. And this ends my presentation. Thank you very much for sharing your time in this webinar. I hope you have learned a lot from this presentation. And by the way, if you want to seek a consultation with regards to your research, we have a page from our department. So we created the CAS Mathematics Facebook account. We offer free consultation in research for one session only. And then I have also a YouTube which you can find and check if you want to apply the statistical test that you have learned here using PHStat. Doc Tony, do you have any questions or clarifications?
Okay, thank you so much, Doc, for that, for shedding light on the most common statistical tool we use in research. Madamo gid nga salamat. It was a very comprehensive discussion. It is very significant and useful to all of us, especially to our nursing students, researchers, our level 3 students who are currently working on the research paper. So let me check if our participants are still with us. May I see any reaction emojis, Be? Or a clapping hand, a thumbs up, a heart? May I see? Okay, madamo gid nga salamat. Now, if you have any questions, as mentioned by Doc Abella to you or with us, okay, if you have any question pertaining to the presented topic, you may type your questions in the chat box, or you may raise your hand for me to acknowledge you. Anyone? While we are waiting, I would like to inform our participants that you will receive a certificate for attending this webinar. That is after you answer our evaluation. Link will be posted in the chat box. Do we have any questions? Wala? Raise your hands. Anyone? I think everybody clearly understood the presentation of Dr. Geraldine. Wala question. Okay, as our appreciation to our resource person for her time, knowledge, and expertise shared with us, may I request Dr. Tony Anlachica to present to us the certificate of appreciation.
Good afternoon again, and Doc GEG, very
impressive. The College of Nursing is so very blessed to have you. I've learned statistics from my master's degree and one from my PhD degree, but now we only we learned this for 2 hours with Dr. Gigi. We are very happy, Doc, that indeed we are right in choosing our speaker this afternoon. And I have read the last slide, and it is actually perfect how we started this afternoon. I told the group that we will dissect to diagnose the data when we write conclusion and findings. So Dr. and then her discussion with postmortem. Okay, and researchers' mind really need, minds really need thinking. So again, Doc G, thank you so much on behalf of Dr. Shaila Trajera, who will give also her closing message, and of the college officers, faculty, and RAS facilitators, students. Thank you so much for sharing everything, almost everything to us. Very clear and very, very simple way of presenting and discussing stat tools. So certificate of presentation is hereby given to Dr. Geraldine Abella on a topic entitled Commonly Used Statistical Treatment and Analysis in Nursing Research during the USLS College of Nursing virtual research webinar held on November 11, 2021 via Zoom at the University of St. Salle, Bacolod City. Signed, Dr. Shaila Magbanwa Trajera, Director, Center for Linkages and International Affairs. Signed, Dr. Jocelyn Mayflower A. Cadena, Dean, College of Nursing. Signed, Dr. Romeo Terwell, Assistant Vice Chancellor for Research and Engagement. Again, thank you so much, Dr.
Thank you, Dr. Tony. Thank you to the participants who participated in my interaction, who participated in the activities I prepared. Thank you for the overwhelming response also. And I hope you have learned something from this webinar.
That's for sure, Doc Dre. We learned so much from you, Gid. And to formally end our program, may I request our ever dynamic director for the Center of Linkages and International Affairs, as well as our very own research coordinator in the college, Dr. Shaila Trajera.
Thank you, Ms. Dean. This afternoon's webinar is an exemplar sharing of knowledge of a fellow esteemed asylum mentor, Dr. Gigi Abella, with engaged 215 participants on the commonly used statistical treatment and analysis in nursing research. Indeed, our nursing research books presented statistics in its simplest way. However, this afternoon's webinar further clarified statistical concepts both in descriptive and inferential ways with the use of a practical tool, PH-STAT. On behalf of the College of Nursing Dean, Dr. Jocelyn Mayflower Cadena, and the overwhelming support of our Center for Research and Engagement, Dr. Romeo Teruel, our Level 3 Chairperson, Dr. Tony and La Chica. Thank you, Dr. Gigi Abella, for this afternoon's webinar. A lot has been learned. To everyone, our nursing faculty and student nurses, as well as our participants who took time in joining this webinar for your engagement today, our Nursing Research 1 Lecture and RE Facilitators team is one with you that this retooling is indeed a success. This afternoon's webinar will be shared in the USLS College of Nursing NRS YouTube channel for your review and future reference. Can you fill up the evaluation form for your certificate in this afternoon's webinar? Have a pleasant afternoon spent with your family and enjoy your academic break, our dear students. God bless you all.
Thank you so much, Dr. Trajera. To all our participants, please put into good use what you have learned this afternoon and practice. No one acquired a skill in just one day. It comes from a consistent practice. Thank you so much for joining us today and have a great rest of your day. Animo Lasal.
Animo Lasal.
Bye! Salamat!
Hail, hail, Alma Mater. Mater. Hail to De La Salle. We'll hold your banner high and bright, a shield of green and white. We'll fight to keep your glory bright, and never shall we fail. Hail to thee, our alma mater. Hail, hail, hail. Hail, hail, alma mater. Hail to De La Salle. We'll hold your banner high and bright, a shield of green and white. We'll fight to keep your glory bright, and never shall we fail. Hail to thee, our alma mater. Hail, hail, hail. Hail to thee, our alma mater. Hail, hail, hail.
Good afternoon, everyone. Thank you so much. Can you please try to answer the link for the
Okay, thank
evaluation?
you everyone. Thank you.
Thank you, Doctor. Thank you,
Thank you.
Doppler. Thank you.
Thank you.
Thank you, Doc.
Thank
Ay,
you.
thank you,
Thank you,
Miss
Dr. J.
Thank you.
Thank you, OJ.
Thank you, Sir OJ. Thank you, Miss Tin. Thank you, Francis. Thank you.
Bye.
Thank
Thank you,
you. Okay, thank you
all
again.